Now let's do some examples with friction. We'll take some numbers and a few different cases. So let's say we have a example 1. We have a flat surface and this is touching the surface, and we're pulling to the right with a force of, let's say, 20 newtons, and the mass of this object is, let's say, 5 kilograms. So it's going to be mg, and that's going to be n. And let's say there's no friction. In that case, we write the sum of forces in the y direction equals, there's no acceleration this way, so z equals 0, and in the positive y, that's the x, that's the positive y, we have normal minus mg, positive upwards, negative downwards, equals 0, and therefore the normal force is mg. And now we apply the equation in the x direction, equals max. We could have written may here, but ay is 0. And in the x direction we have 20 newtons equals the mass, which we took as 5 kg, times a, and this gives us ax equals 20 over 5 is 4 meters per second square. So it's going to accelerate at 4 meters per second square. Now let's suppose that in this case we have friction and the mu s is 0.3, and the force that's pulling it is 20 newtons. Is this force enough to cause it to start moving? Let's check. So the normal force is going to be mg, so the maximum static friction will be mu s times n, which is 0.3 times the normal force. Okay, that's mg, so we write m is 5 kilograms times 9.8, and that becomes 9.8 times 5 times 0.3 becomes 14.7 newtons. So this is going to be pulled to the right with a force of 20 newtons and pulled to the left with a force of 14.7. It will reach the maximum value. And so the x equation gives us that it's going to be, the force to the right is 20, the force to the left is 14.7 equals 5a, and 20 minus 14.7 is 5.3 over 5 is 1.06 meters per second square is ax. So it's going to accelerate. Instead of 4 meters per second square, it's now going to accelerate only at 1.06 meters per second square. Now, as soon as it starts accelerating, the coefficient of friction changes. So this answer is not exactly correct. What we need to do now is, since it has started moving, we need to solve the equation for kinetic friction. And let's say the kinetic friction is 0.25. So the sum of force in the x direction should be written as max, and the friction, this will be F minus F equals max. The friction is going to be mu k times n, which is 0.25 times the normal force, which is 5 times 9.8. So that is 5 times 9.8 times 0.25, it's 12.25. So this will now be 20 minus 12.25 equals 5a, which will give us an acceleration of 20 minus 12.25 divided by 5, which is 1.55 meters per second square. So this is the acceleration and not this, because this was with static friction. This just tells us that yes, it is going to accelerate. This is the value. Now, as another example, if the force is pulling like this, and let's just say it's still 20 newtons, and it's at an angle of 30 degrees, then and we have a mu, let's say S equals 0.30, same as before. So now is this going to move to the right or not? And if it does, what will be its acceleration? So we can go back and find out whether the friction is more than the x component of the force, and then we'll know that yes, it is going to move, and then we'll use this to find the acceleration. So the first thing we do is make a sketch, which we have. Then we make a free body diagram. So we have this is the F, so we have the Fx, this becomes Fx, this becomes Fy, we have a normal force, a weight, and a friction, which could be static or kinetic. So now we use the sum of forces in the y direction equals 0. Normally in the y direction the acceleration is 0, so we could write it out as MAY equals 0, because this is 0. Now in the y direction we have the normal force, we have the Fy, both upwards, and we have the mg downwards, and they should add up to 0. And therefore the normal force is mg minus Fy, which is going to be mg minus F sine theta, and mg, if the mass is still the same as 5 kilograms, 5 times 9.8 minus 20 sine 30, so this is 49 minus 10, that is 39 newtons. This is the force, that's the normal force, and therefore that's n. Therefore the friction static max is 0.3 times n, or better written as mu s n, 0.3 times 39, 11.7. That's the maximum static force that's preventing it, and the Fx is going to be more than 20, so it's 20 cosine 30 cosine 30 should be 0.866 times 0.3 times 20, 17.32. so Fx is going to be 17.32, which is greater than the maximum static friction, and therefore it's going to move. So we need to use, in the x direction, max, the force is going to be Fx minus the kinetic friction, because it's going to slide, so we have the kinetic friction equals max. The Fx is going to be 17.32, and the friction is going to be mu times n, mu k times n, equals max. So that's 17.32 minus mu k, we took as 0.25, times the normal force, which is 39. Note that normal force is not mg, and we divide this by m, which is 5, and that's ax. And so this becomes, that's 39 times 0.25, and we have 17.32 divided by 5, so it's 1.51 meters per second square. So even though the horizontal component of the force is much smaller than what we have in the previous example, where it was 20 newtons, yet the acceleration is not very much different, and the reason is that the normal force has decreased. in this case, the normal force was 49, and in this case it's 39. That's because this force pulling upwards is sharing the weight, and the normal force or the push from the ground does not have to be as much. And because the normal force decreases because of this component, the friction decreases, and the friction decreases and the Fx decreases, and we have this value of acceleration. Now, had this force been different, had this force been pushing downwards from the left side, same magnitude, same angle, well, then when we do the normal force, it would be much greater than what we had before, and so the force of friction would have increased, and the acceleration would have decreased.